right, so picking back up with number 25, we had y is equal to x cubed minus 2. And they asked us, what's this minus 2 going to cause to our original toolkit function y equals x cubed? Now, this minus 2 can be added to the other side. Whereas like in number 24, that 2 was stuck to the x. It could not be moved to the other side. So when it's stuck to the x, it's a horizontal shift. When it can be moved to the other side, that's a vertical shift. So any value being subtracted from y, that would be y minus a negative 2, or the opposite of positive 2 is negative 2. If you leave it over here on the right-hand side, don't do the opposite of it. So that would be a vertical shift of negative 2. All right, then when you put a negative out in front of the entire function, that causes a reflection in the x-axis. Reflection in the y-axis is when you put a negative just in front of the x and plug it into the function. All right, then for number 27, they asked me to find f plus g of 1. So that would just be f of 1 plus g of 1. So f of 1, that would be 1 over 2. G of 1, that would be 1 over 1 squared. So 1 over 2 plus 1 over 1 squared is going to give me 1.5 or 3 halves. For 28, they asked me to do f of g of x. So let's start on the inside with g of x. G of x was the square root of x plus 5. So let's replace g of x with the square root of x plus 5. So now we have f of the square root of x plus 5. That means we're putting the square root of x plus 5 in the place of x. So we're going to put the square root of x plus 5 right there. So that means we're going to take that square root and square it. So we took our square root and squared it. The square root and the square cancel each other out, and that gives us x plus 5. All right, then the next one was g of f of 2. So start on the inside again with f of 2. So if I put 2 in for this x, that would be 2 squared, or 4. So f of 2 is 4. Now we have g of 4. So g of 4, if I put a 4 right here and a 4 right here, then 4 plus 5, the square root would be 9, and square root of 9 would give us 3. Then for number 30, they asked us, is this a one-to-one function? So easiest way to do this is to just go to y equals on your calculator and type the equation x minus 5 over 3 in and graph it. So when you're looking at the graph, if it's a one-to-one function, it's going to pass both the vertical and the horizontal line tests. So this one you can see it does pass a vertical line test. If I draw vertical lines, I don't hit it in more than one spot. So that means it is a function. It also passes the horizontal line test, and that means that it is a one-to-one function. For 31, they ask us to find the inverse of a function. So to find the inverse, we switch x and y, and then we solve for y. So first off, this is y. F of x is the same thing as y. So first thing we're going to do is you can see we switch the x and the y, and now we're going to get y by itself. So let's multiply both sides by 4. And then to get rid of this square root, we're going to square both sides. So 4x times 4x would be 16x squared. And then here the square root and the square cancel each other out and give us y plus 2. So to get y by itself, we'll just subtract 2 from both sides, and that would be our inverse function. All right, for number 33, they asked us to find the maximum. Remember, the maximum always occurs at the vertex, and the easy way to find the vertex is just to do negative b over 2a. But be careful, this is not in descending power order. Remember, a is what's in front of x squared, so a would be negative 0.01. B is what's in front of x, so b would be 16, and c is the constant, so c would be 100. So when I do negative b over 2a, that's going to give me 800. So if they ask me how many units do I need to produce, that's my x value. If it says then what's the maximum profit going to be when I produce that number of things, then I would plug the 800 back in for x in this function to actually get my maximum profit. So it also could have asked us to find the maximum profit, and that would have been the y value. All right, for number 34, they give us this function and ask us for our end behavior, which basically how it starts and how it stops. So when the leading coefficient is negative, that means that it's going to end going down. And then my degree is 3, so I know it starts and stops in opposite directions when the degree is odd. So if it ends down, then it's going to start up. So if this instead had been an even number, for an even exponent, they start and stop in the same direction. All right, then for number 35, they ask us to solve this and give the x-intercepts, or the solutions, or the roots, or the zeros, all synonymous terms. So step number 1, take out your greatest common factor, and then what I'm left with is a quadratic that I can factor. So x squared was x times x, and then what multiplied to be positive 2 and added to be negative 3 was negative 2 and negative 1. So that would be x equals 0, x minus 2 equals 0, so x equals 2, and x minus 1 equals 0, so x equals 1. So these would be my x-intercepts then. All right, for number 36, remember that when your leading coefficient is positive, then your parabola is going to open up, and that means your vertex is going to be a minimum. If your leading coefficient is less than 0, that's negative, then your parabola opens down and your vertex would be a maximum. All right, then for 37, they ask us to divide 1x cubed minus 2x squared minus 14x plus 3 by x plus 3. All right, so remember what goes in the box over here is the opposite of that x plus 3, so it would be minus 3. And then we've got our coefficients across the top. So we're going to bring that first one straight down, and then 1 times negative 3 goes in our next column. Combine those to get negative 5. Negative 5 times negative 3 is positive 15. Combine those to get 1. 1 times negative 3 is negative 3 combined to get 0. So when I go to write my answer, remember that we always start with 1 less. So this was a cubic being divided by x plus 3. So we're going to have 1x squared minus 5x plus 1, and then a remainder of 0. So if they asked me if it was a factor, then yes, it would have been a factor because the remainder was 0. For 38, they asked me if 2 is a factor. They also could write that 2x to the 4th minus 5x squared plus x minus 3 divided by x minus 2. And say, is x minus 2 a factor? All right, so remember the shortcut is the same number that you would put in the little box. So like if it's x minus 2, the opposite of that is 2 that would go in that little box for synthetic division. That is my k value. That's the same thing that I'm going to plug into the function to get my remainder. So I'm going to put 2 in for x, 2 in for x, 2 in for x. So that's going to give me 2 to the 4th is 16 times 2 is 32. 2 squared is 4 times negative 5 is negative 20 plus 2 minus 3. So 32 minus 20 is 12. 12 plus 2 is 14. Minus 3 is 11. So that would be my remainder. If they had asked me, is it a factor? No, it wouldn't be because my remainder is not 0. All right, then for this next one, same thing. They want to know, is x minus 1 a factor, or is x equals 1 a factor? They could write it either way. So x minus 1 or x equals 1. So again, remember, I'm going to put k in for x, and the answer that I get is negative 5. So no, it's not a factor, because if my remainder is not 0, it's not a factor. If my remainder is 0, then it is a factor. All right, then for number 40, they asked us to find the possible rational roots. So we're going to put our p's over our q's. So p is going to be the factors of 6. So that could be 1 times 6 or 2 times 3. And all of those could be positive or negative. And then 2 is going to be positive or negative 1 and positive or negative 2. So if I put all my p's over all my q's, then I'm going to have 1, 2, 3, and 6 over 1. So that's where the 1, 2, 3, and 6 come from. All right, then we're going to go back and put all those over 2. So that would be 1 over 2. So there is our 1/2. 2 over 2 is the same thing as 1. We already have that. 3 over 2 is where this 3/2 comes from. And then 6 over 2 is 3, and we already had that one. All right, then for 41, we had the square root of -4 times the square root of -9. So remember that the square root of a -1 is I. So we know the square root of 4 is 2, and then the square root of -1 would just give us 2i. Same thing, we know the square root of 9 is 3, so the square root of -1 would be I, so that would give us 3i. So 2 times 3 is 6, and I times I is I squared. Now, I squared is the same thing as -1, so we could say -1 times 6 and get -6. All right, for adding and subtracting, the first thing that we need to do is we need to simplify the square root of -18. All right, so we know that 18 is 9 times 2. So I could say the square root of 9 is 3, and I could pull a 3 out, but I would still have 2 underneath. Also, this square root of negative is going to give us I. All right, so you can see right here, like we said, we've got the I for the negative, and then 18 was square root of 9, which was 3 times square root of 2. All right, so now that we've got all these simplified, now we can go through and distribute our negative. So that's going to be -3 and -3 square root of 2i. So to combine like terms, 7 minus 3 is 4, and then a positive 3 square root of 2i and a -3 square root of 2i cancel each other out. For 43, we're going to FOIL, so we're going to say 2 times 3 is 6, 2 times 4i is 8i, -I times 3 is -3i, and -I times positive 4i is -4i squared. So I squared is the same thing as -1, so we would have -4 times -1. And then combining like terms here, 8i minus 3i is positive 5i. So -4 times -1 is positive 4, so 6 plus 4 we could combine to give us 10. And we're going to write our answer in a plus bi standard form, so a plus bi. All right, then for 44, we had 2 plus I over 2 minus I, and we're not allowed to leave an I in the denominator because that's the square root of -1, and you can't have a radical in the denominator. So we're going to multiply by the conjugate. It's the exact same numbers, but the opposite sign in between. And what I do to the bottom, I do to the top. So let's FOIL our numerator. So 2 times 2 is 4. 2 times I is 2i, and 2 times I is another 2i, so that's our 4i. And then I times I is I squared. In our denominator, 2 times 2 is 4. 2 times I is 2i, and -I times 2 is -2i. I times positive I is -I squared. So the positive 2i and -2i drop each other out, and remember that I squared is -1, so this I squared becomes -1, and this I squared becomes -1. So 4 minus 1 is 3, so that'd be 3 plus 4i, and 4 minus a -1 is 4 plus 1, that'd be 5. And then we're going to write it in a plus bi form. And so we're going to separate this into two separate pieces. So 3/5 plus 4/5 times I. All right, for 45, we're working with the rational function 1 over x minus 2. And they want us to find the x-intercept. So the x-intercept is just where y is equal to 0. So if we set this equal to 0, there's no place that these are equal to each other, so I have no x-intercept. My y-intercept is where x equals 0, so I'm going to put 0 in for that x right there. So that would be 1 over 0 minus 2, or -1/2 for my y-intercept. My vertical asymptote is just where the denominator equals 0, so I'm going to set x minus 2 equal to 0, so that would give me x equals 2. If you have a horizontal asymptote, you won't have a slant asymptote, but for the horizontal asymptote, we compare the degree of the numerator and denominator. So for this one, the degree of the numerator was 0 and the degree of the denominator was 1. When the degree of the numerator is less than the degree of the denominator, then y equals 0 will be your horizontal asymptote, which was the case here. If the degree of the numerator and denominator are the same, you would take the leading coefficient of the numerator over the leading coefficient of the denominator. And if the degree of the numerator is larger than